Started.
Hello, we are Group 4. Our team members, Hiva and Bijoy, and that's Vishu Rasani. In part A of our project, we focus on deepfake detection in cybersecurity. We explore how AI-generated media can be abused in real attacks and what technique exists to detect and mitigate these threats. So now, on this slide, I introduce basic concept of AI deepfakes. Deepfakes are AI-generated or AI-manipulated audio, image, and video that can closely mimic real people. They are usually created using advanced generative model. Since around 2020, the quality of this model has improved so much that it's often hard to humans to tell what is real and what is fake. So now, slide number 3. Uh, Motivation and problem statement. This slide, we explain why deepfakes are a serious security problem. Today, deepfakes are not just experiment in research lab. They are operational tools in phishing and social engineering campaign. Attacker can use them to impersonate executives, employees, or trusted officials. For example, to approve payments or request sensitive data. This attack can bypass classic anti-phishing training. So our main goal in this project is to understand how deepfake are weaponized in this scenario and how defenders can reliably detect them. Okay, now number 4 slide, real world case. Here we show a real case that illustrates the impact of deepfake attacks. In 2024, a finance employee was tricked during a multi-participation video conference where several people, including a supposed company executive, were actually deepfake. As a result, the employee authorized a fraudulent transfer of about 25 million US dollar from a company in Hong Kong called Adobe. This incident proves that deepfakes are not just theoretical; they can directly lead to large-scale financial losses. It also shows that organizations need to new verification workflow going beyond simple email check when approving high-value transaction. So now I'll tell about detection approaches overview. Slide number 5. On this slide, we give a high-level overview of how deepfake detection works. First, there are visual detection methods. Second, there is a audio detection and anti-spoofing system. We have provenance and watermarking approaches. So finally, there are public web tools, enterprise detectors that combine several techniques. In practice, we cannot rely on just one method. So organization need a defense in depth strategy that combines visual audio and prevents base detection. So now my teammate Vijay will tell about part B.
Yeah, when it comes to part B, we'll go through and implement network simulation, IP spoofing, and prevention in GNS3. In this presentation, I'll walk through how IP spoofing was simulated inside GNS3 and how we applied prevention techniques. We used a controlled virtual environment with l- Linux hosts, FortiGate firewalls, and Cisco routers to both launch and stop uh, spoofed packets. I will explain how the spoofing was done using IP tables and how filtering rules on router stopped this type of attack. When it comes to what is IP spoofing, IP spoofing is when an attacker alters the source IP field in a packet to impersonate on the system. This can make malicious traffic look legal or Anonymous attackers use spoofing in DDoS attacks, trust-based exploits, or simply to bypass basic access controls. In our GNS3 setup, the attacker system forged packets pretending to be from victims' subnet.
Okay, thank you, Vijay. I'll take it from here.
Okay.
So on the in the part B, we have network topology. We have two networks, attacker machine and a victim machine. These are two Alpine Linux hosts. In between, there's a switch and also a firewall for added extra security feature. And let me just in the slideshow, I'm pulling up the GNS3 software right here. So this is our network topology, and we have here missions connected through a switch, through switches, and all of them are online. They're running in GNS VM, and I'm going to give a hands-on demonstration on IP spoofing. We have selected IP spoofing attack simulation because it closely relates to our deepfake detection, which is also about spoofing someone else. And our lab objective mainly is to send a spoofed IP. We need to spoof an IP address and send packets from Linux, this machine Linux, to other end Linux 2. This one is attacker and this one is victim. So let me just open up the consoles I have right here. I have configured them already, and I have the report written in the part B of the report. And this is our, if you can see, this is our Linux 1 machine. I'm trying to uh, ping the machine 2 from here. So for this, this is a machine 2 IP. I'll show you this one. If you see, this is a Linux 2 machine. We have a IP address right here. So I'm trying to ping this machine from here. And you can see the network layout. I'll show you it once again. So the packet travels from right here to all the way till here. So when I do a ping, I'm opening up the Wireshark. So see, the ICMP packets are being sent through the network. So these are all the latest ones. And let me just stop the packets. Yeah, 27 packets transmitted. This one. So I've added a rule. I've used an IP tables. I can show you the rule. So it says SNAT ICMP anywhere destination. This to this source IP. Uh, this is the spoofed IP address. We are using this command post routing. We're appending this rule. So this spoofs gives I mean sends the packets using this spoofed IP address. And in the router, we are setting access control list to permit only the this one IP address. This is our original IP address of the Alpine Linux. I can show you right here. Let me just pull it up. If config. So as you can see, this is our original source IP. We're only permitting that one, the subnet, and denying anything else. So when we are making this rule, we are we are sending packets from this IP address. So this is a spoof IP address. We want it to be blocked. We want the packets to be dropped. So this will deny any packets. As you can see, there are 2830 matches. That means it is incrementing when the packets are going through. It is incrementing, meaning it is dropping the packets right here. So when I just do this one, ping the destination victim mission. So some packets are being sent, and when I give this command, you can see the increments are increased. So the packets are being dropped from the router and they're not reaching the destination. So if I stop this and if I delete the rule, I can use D to D-D to delete this rule. And I can show you the IP tables. There are no rules. And if I do a ping now, the packets will go through the router and they will reach the victim machine. So let me just show you the Wireshark. See, if I scroll down, you can see the packets are reaching. So this is when the access control is not active. Let me just stop the capture and show it once again. We want to append this rule. And we can see the rule is appended here. This prevents the IP spoofing attack. So let me just bring up the console again and ping it again. So start capture, continue without saving. Okay. So as you can see, this is the last packets that are delivered. There are no new packets being delivered right now, even though the ping is still going. And if I do a show list, you can see it's incremented again from 29828 to 2986. This means the packets are being blocked at the router. So that's our IP spoofing attack done, part B of our attack. So we have successfully created a network, secure network environment, and we simulated an IP spoofing attack and also blocked it using access control list. So that's our part B of our project. Thank you so much.